Bonjour à tous, encore une fois.
Yes, hello and welcome to our talk today where we're talking typesetting, which is going to be about designing and building beautiful text layouts. So my name is Nick Butcher. I am a designer and engineer at Google.
And I don't have so many fancy titles. I'm just an engineer at Google.
Just an engineer, please. So yes, today we're here to talk about type. So type text is like incredibly important. It's how you convey most of the information in your application to your users, but it's also an incredibly complex rabbit hole of decisions you have to make. I like to think that good typography is a bit like hygiene, in that you don't really notice it when it's good, but if it's bad, then you suddenly start noticing it. So don't have typography that stinks, and learn from this talk, hopefully, how to do good typography.
And apart from this, we'll also see how to implement everything that Nick will design. It's going to be a lot of fancy things there. And while we're doing this, we'll also see how things work under the hood, just to make sure that we're setting text for performance.
Yep, so throughout this talk, we're going to take this example of the abstract for this talk here and say, if you were to set it on a view with any styling information, it doesn't really give the user much to go on. And hopefully you'll agree that the version on the right, where we've applied some styling and a bunch of decisions, reads a lot better, conveys the information a lot better. But as we say, there's a ton of decisions that go into this, so we'll go through this from both a design and implementation point of view about how you make these decisions. So a lot to cover, so we're going to go straight into this. First up, the basics of text. The first thing to think about is the layout, actually where you put the words on the screen. And when you talk to designers about layout, they'll probably go fancy on you and talk to you about things like this, which is a depiction of Gestalt theory, which is how humans perceive and understand the world. This is how describes how you look at this slide and you don't see 40 dots. You see a group of 20 and two groups of 10. You see that the proximity between them makes you link them together and understand them to be connected. So that's the underlying principle about laying out pretty much everything in your applications. So in our sample application, we're just going to put some space between the title at the top and the abstract below. So instantly, as soon as you look at this, you kind of say this is these two are related, and this thing is slightly separate. When you get spacing information from designers, how often have you seen this? Someone has drawn something in Sketch or Photoshop or whatever with an exact distance between two elements right up to the very character. That turns out to be not a very helpful way to specify text. Because all software products treat text slightly different. So text has different properties, like especially vertically, when you think about what is the top of a piece of text. Is it the top of the capital letter? Is it kind of any accents on top of it? Certain scripts, such as Vietnamese, have the extremely kind of tall characters that escape it. And software being software, there are a myriad of different ways that they handle this. This is why that if someone gives you a design, it says this should be exactly this size between the very base of this character and the top of this character here, you might get knocked back saying, hey, this isn't to spec, this spacing is slightly wrong. A better way to think about text is about thinking about baselines. So the baseline is, as it says, the line that the text kind of sits on. And this is pretty much the only stable thing you can think about when talking about the vertical measurement of text, because all software treats baselines the same. So as such, when specifying text, we have found that the best way to specify it is by the distance from the top of the element to the first baseline, like this. Now, unfortunately, not a lot of software really supports this right now. So if you're going to get your handoff from Zeppelin or something like that, they don't specify it this way, but we're working with some software vendors to try and make this widespread. One tip for designers out there is if you do want to specify text like this, if you're in Sketch and you kind of select one element and hold Alt and hover over another element, which is their measure mode, which actually measures the distance between stuff. If you also hold Control, this will then look at the baseline of the text rather than what Sketch considers the bounding box of the text. So this could be helpful if you're trying to set it this way. Cool, so that was layout. And the next very, very basic thing you can use in your text is size or scale, as designers call it. So here we can just say that the title is more important, so we're going to make it bigger. Very, very simple stuff. Conversely, you want to be a bit careful when playing with size, because saying that the title is bigger draws your attention to it, and it makes it easier for you to understand that this is the most important thing and this is less important. But be careful, don't use like a huge variety of type sizes, because the opposite thing happens. You actually end up having to work harder when there's like changes to be 4 or 5 different type sizes in the same block, and kind of your brain's scrambling to try and like understand the hierarchy of what's going on right there. As such, it's a good idea to restrict yourself to a scale, as designers call it, of a limited set of type sizes, which you use throughout, so you don't have this huge variety of different sizes throughout your application. Next up for type is thinking about the color. So while I made the text of the title bigger because I wanted it to be prominent, it kind of ends up being a little bit too prominent. So I'm going to do a subtle change and just turn down the color a little bit. And also that strapline, the names, I'm going to make that lighter color as well, because again, that's less important. So if I were to block out the text on screen, just using these colored lines, the idea here is that you can instantly, as soon as you glance at the page, get an idea of what is important. This is all about like screaming out to the user, this is the hierarchy of information. This is the most important thing. This is slightly less important. This is quite important kind of thing. When we're setting colors on text, we tend to use opacity rather than using fully opaque gray, shades of gray. The reason being that if you were to change the background or something like this, some of the color slightly bleeds through with the opacity, and it ends up being looking more at home, versus if you use a shade of gray, it can look really bad on some backgrounds. So opacity works well here. You also want to be wary of using fully opaque colors as well. So fully opaque black on a white background can be too stark as well. So a little bit of opacity actually makes it easier on the eye to read versus being too high contrast. Speaking of contrast, you want to be extremely careful when dealing with contrast not to go too low. I know some designers love really gray text because it can look fine, but be very careful about this, especially for visually impaired users. So you want to be checking the contrast ratio, which you can calculate in your design tools like Sketch and so forth, or there's an app, what's the TalkBack app? I can't remember.
The TalkBack app? Yeah, that's good.
There's one that uses a TalkBack service, which will warn you if you're using insufficient contrast, but basically watch out for that.
I'll let you breathe a bit, because you've gone through a lot of things, and let's see how we can actually implement these. So we'll start with the layout. So we would use the margin horizontal, vertical, margin top, so the elements that we already know. But we've seen that designers don't really think like this. Designers think more in stuff like the first baseline to top height, but also the last baseline to top height. So this is why in P, we've added these 2 new attributes. So making it easier to bridge this gap between designers and developers. Then, when we're talking about size and scale, we're used to just setting the text size based on some dimension. But what's even better to use is to set up some text appearances and actually stick to them afterwards. So you can either extend from the text appearance.material or text appearance compat, or directly use those. And then, if you want your text to automatically scale based on the size of the text view, you can use the Autosize text type with the value uniform. So what you should be careful here is that the width and the height need to be either a match parent or a fixed size. Otherwise, you'll end up with unexpected things. But because we also want to respect the scale that Mick was mentioning, we also have the Autosize preset sizes attribute. So this allows you to define a set of sizes, and then the size of the Autosize text will scale to the biggest one that actually fits the text view. Then in terms of color, we can just use the text color attribute. But even better than just setting the color that we define in the colors, we could use a theme attribute. Like this, we're avoiding using way too many colors in our application. And then even more, using this, it means that automatically we'll have support for the dark and the light theme. I'll let you pick some more, push some more pixels.
Cheers. All right, so next up we're going to look at the line spacing, or as designers like to get fancy and call it leading, which, fun fact, refers to the days when text was on printing presses and they used to put lines of lead between them in order to change the spacing between lines. So if someone calls it leading, they're mispronouncing it, and you can laugh at them, it's leading. So line spacing, the vertical space between lines of text. Here, we've just made a very simple change and just increased the line spacing between the lines. And the idea here is it makes it much easier for your eye to read, especially going across a line and then looping back to the start of the next line. If it's too far apart, like this, the lines feel unrelated. Think back to that Gestalt diagram we looked at before. So that becomes harder to read. And conversely, when it's very, very tight, it's harder to read again to get back to the start of the line. So basically, what you want to think about is setting how much spacing there is between those lines, and that needs to depend on the font size you're using. Generally, as a rule of thumb, around 1.2 times the font size gives you a good line spacing. But quite commonly now, instead of referring to it as a multiplier like 1.2, we're setting these discrete lines as the amount of spacing between the lines. So if you look here, this is an example taken from the material spec. If you look at, say, the headline type, it says to use a 24 SB font and set the line spacing or the leading to 32 dp. And this is actually kind of a more helpful way to think about it in many ways, partly because this is how designers think. So here I am back in Sketch, for example, and when I specify a type size, a font size, it lets me specify the line height as a specific line height rather than using those multiplier attributes you might be familiar with. But this also really helps you to achieve what Material, again, advises you to do, which is to use a baseline grid. So it says to use a baseline grid of 4 dp to make sure that lots of things like have a regular rhythm and line up with one another. So the way you would do that is you basically set a line height, which is a multiple of 4. So that was line spacing, which is the vertical distance between text. And we can also do the horizontal distance between text, or the character spacing, or tracking, as designers like to call it. So I'm going to apply a small tracking change here to the title. You can see this large text at the top. I'm just going to tighten it up a little bit. The reason being that the way that font metrics work, when you go to larger font sizes, they have a tendency to spread out. So here you can take a look at the text at 1x, and this is at twice the font size. And you can see that the larger one feels like it's getting more spread out. If I were to use the same as the same large font size, but then apply a -2% kind of tracking change to it, we achieve the same kind of feeling because of that font change. And the last thing I want to talk about is about line breaking. So the things you want to watch out for essentially here is having kind of unsightly gaps. So in this example here, I've highlighted areas where you kind of like have these big gaps, or what we call orphans, which is a line, a word, sorry, on its own line like this. Again, this just makes it harder for the eye to scan across when you don't have a regular kind of rhythm to it. So you want to avoid these kind of problems.
Okay, so line spacing, character spacing, and line breaking. Okay. So for line spacing, we already have 2 attributes, the line spacing multiplier and the line spacing extra. But as again we find out, designers work with other values, which respectively is the line height. That's why in P we've added the line height attribute. So from what we know, there's actually nothing that would stop us to have all of these attributes also to the support library, so let's hope that happens soon. In terms of character spacing, we have the letter spacing attribute that we can use. That was easy. In terms of line breaking, we have the break strategy. So we have 3 types of break strategy: simple, balanced, and high quality. High quality by default also adds hyphenation to your text. But you can set which kind of hyphenation you want. So we have 3 different types of hyphenation frequency: none, normal, and full. So when the framework wants to draw your text, the first thing that it needs to do is, wants to lay out your text, the first thing that it needs to do is measure it. So it wants to do this in an optimized way, and this is why it's building a word cache. So this means that it will keep one reference of all of the words, and then it will know how to measure that word. So then the next time when it encounters that word, it already knows how it should be measured and how much space it occupies, and it doesn't need to do that again. But for example, if you have words that look similar, so for example, the and the with a capital letter, those will be 2 different keys in this word cache. Even more, this cache actually depends on the font and the locale. So for example, if we have a text view written in a comic way and a text view written with a monospace font, then it will keep 2 instances of these kind of text in the word cache. Even more, if you have hyphenation enabled, it will keep all the possible ways of breaking that word. So for example, for typesetting, it will keep typesetting, but also typesetting and typesetting. Complicated. Okay, let's see more.
Thank you. Okay, fonts. So picking fonts could be a talk in of itself, and I'd love to give it one day. But it comes down to a few things, really. So when you pick fonts, you're looking for kind of some aesthetic, some technical, and some functional choices. By the aesthetic, I mean the style of the font kind of really communicates the emotion, the feel of your app, what your app is all about. So for example, these 2 pieces of text wouldn't really work in the opposite font, right? Would you trust Shield Bank with that branding?
It's
like,
gonna be
yeah.
a funny bank.
Yeah, I guess so. So fonts themselves have a number of different attributes to them which make them appropriate or inappropriate for different circumstances. So let's take a look at this word in two different fonts. So at the top we've got Alegria, which is a serif type font, and underneath is Open Sans, which is a sans serif, kind of like a humanist font. Now, in and of themselves, these two differences mean they're appropriate for different contexts. So the serif fonts, for example, can be easier to read in longer blocks of text because we're used to reading them in like newspapers and textbooks and so on. But they don't really work very well when they're scaled down. Due to the extra serifs on them, when you scale down, the font weight gets heavier and the color kind of doesn't average out as well. So it doesn't work great at small sizes. Versus like the sans serif, the open sans here, for example, it doesn't work very well at larger sizes. It can feel awkward, so you have to go up to different weights. So if we were to overlay them like this, you can see that fonts have a huge variety in the way they look. So this is the same size, but you can see they all have different metrics to them. One thing to look at is the x height, which is the height of the lowercase x. And you can see that on the sans serif, it's much kind of taller, and that makes it work better at smaller sizes, but again can make it feel awkward at different weights. Another thing to look out for when you're choosing fonts is the variety that the font itself offers. So fonts come in different weights, for example. So Alegria offers regular, bold, medium, and black, and whatever one I'm forgetting, different weights. And this can be really helpful if you're trying to display hierarchy in your UI. You're trying to say, show variation without having to revert to using lots of different colors or sizes like we talked before. Using different weights can be really helpful to get that variety and show the difference between information without having to do that. So when it comes to choosing a font, there's kind of like almost two jobs to be done that you need to consider. The first one, which I kind of call text here, is that a font needs to do a lot of work. It needs to convey a lot of information. It needs to kind of, say, work at small sizes in captions and so on. It needs to work maybe in a context next to an icon or in a button, or maybe need to appear in a block, like a large run of text. So that's kind of like one job, but like text also serves a different job. So what I think of it as display type tends to be in larger sizes, and its job is much more about expressing the brand, the feel of your application. So you might not just pick a single font. You might want to pick multiple fonts that do these jobs well or pair well together. So I can give you some examples of like body text. So Roboto is a great example. That's our system font on Android, and it does a wonderful job of working in all of those variety of different contexts, working in different sizes and so on. But it's not going to convey a lot of branding. You're not going to feel like a very branded application if you use Roboto everywhere. So I can't really give you a huge amount of advice on what to pick for a display font, because that comes back to that kind of emotional side of it, that kind of branding piece, the feel that you're going for in your application. So let's use some fonts in our sample. So I'm going to set the title here in, this is Product Sans, Google's brand font, which has this like nice rounded feel, which I think fits what we're trying to do here. And I'm going to apply Lato, which is a good body font, to the body here.
So designers speak a lot about fonts, but for us as developers, this is again pretty easy. So recently we've added support for downloadable fonts. So this means that all we need to do is go to Android Studio, to our XML, and select the font that we want from the Google fonts. This means that it's easy also to use. But there is one thing to remember. So by default, when you're using a downloadable font, it will try to download the font the first time when the text is rendered. But this can take quite a long time. So this is why you can define the fonts that can be preloaded. So this means that when the app is started, those fonts will be loaded. So here you would define in the preloaded fonts XML the list of fonts that you need in your application. And then in the manifest, you would use the preloaded font metadata to actually use it. So by default, Android Studio is helping with this. So these are automatically added as soon as we import a downloadable font in our project. But there's another optimization that you can do that Android Studio doesn't support for now, to do for us automatically, I mean. So you can add the font provider request metadata in the XML. So this will tell the Google Play services that when you install the app, it should also download this font. So you're moving this step even earlier in the timeline. I know you can get better. We can get even better than this. Let's see.
Yeah, fonts, like we say, are a huge world on itself. There's a few features I wanted to call out that you should be aware of when you're choosing and using fonts. So there's a few fancy features, I'm calling it, that you should be aware of. So for example, this is an example of a ligature. So often a font designer will say that a certain pair of letters should have an alternate representation. So a very common one is the lowercase f and I. You can see on the right with the ligatures turned off, they get kind of quite close together, the capital of the F and the dot of the I. So you often get like an alternate form like this. Other fonts will support different features, like numbers, for example, will commonly have a couple of different representations. So this is Roboto, which has both proportional and tabular. This is most obvious if you look at the number 1. So in proportional, because 1 is a narrow character, it doesn't take up as much space, versus a tabular, it acts more like a monospace font, so it will take up the same amount of space. So if you're trying to display like a table of data, then tabular might be useful, because then you can like have alignment so you can scan down columns. Or if you're trying to do something like a stopwatch app, then again, something like tabular can be useful because you don't have the numbers width changing based on which numbers are being displayed. Versus in a body of text, you might want something like proportional because it reads more commonly without having this kind of, seems awkward having this extra space around some of the narrow characters. And there's another alternate style for numbers, which is called old style numbers, which you often get these kind of descenders which go below the baseline. Again, this is just another kind of version of the numbers that the font offers, as well as small caps. So many fonts will offer a small caps representation. So this is kind of like not the same as the capital, like uppercase capital letters at a small size. They actually tend to be redrawn to work at this size. So consider using that. So the kind of point of all these kind of fancy features is that you can, again, avoid using color and size to show different changes. So here's an application I make where I've used small caps and I've used the old style numbers on the timestamps, for example, to give this variety, to show, this is a different type of information without having to resort to lots of different sizes and so forth. All of those features I've just covered are controlled by the font feature setting flag, which comes from the CSS specification of the same name, and you control them with these kind of like stringly type things where you send the name of them. So the first one, liga0, means turn off ligatures, and then the PT and onum is the proportional, tabular, and old style numbers, and the last one is turning on small caps. And when talking about fonts, the new fanciest thing is what's new in Android O is the support for variable fonts. So variable fonts are an effort to kind of make parametric fonts. So instead of having to include multiple different versions of the font, so say you want to use 5 different weights of a font, you generally have to include 5 fonts, which kind of increases your app size and so forth. So variable fonts attempt to address this by making it parametric. So for example here, I can, at runtime, control the different attributes of the font. So I control like the weight, the inlineness, which is how much it's stroked, or the slab, which is the kind of serif terminals on this. And you can do these in combination and so on and so forth. So this has all been done at runtime, so I'm just like changing the seek bars, which is setting this, again, kind of string typed pairs of kind of identifier to value, and the values tend to be arranged from 0 to 1,000, and you just set that on the text view. And the way you find out which features a font supports is, well, they kind of depend on the font. So a font can basically advertise which features it exports, and you set them by this key. So if I go to Decavar, which is that font I was using there, take a look at its README, then we can see the different axes it supports right here. This is incredibly powerful because basically there's very little limitation to what you can do in the font. So here's one of my favorite examples of this is a font. So this font exposes a timeline axis, I think it is, and just by writing to that timeline value, it displays a different kind of frame value. So this is a font, like I say, you can copy and paste. This is text. You can zoom in the browser or the app or whatever it might be, which is kind of powerful, right? There's very little limit to what you can actually do.
Yeah, that's me.
We're about to die of power, so thank you. Next up, I want to go a little bit into styling text, or how you set this in your themes and styles. So far, we've mostly been looking at setting these attributes directly on the view like this, so you're setting the colors and so on directly on the view. But most Android developers, you're probably aware that there's text appearance also exists, as well as it's a view, so you can set a style on it, right? But what happens if you, but which should you use, and what happens if you combine them? What's going to happen here? Does anyone know? Cyril knows. Okay. Well, there's a precedence order is the answer here. So for text view, this is the precedence order. So basically, text appearance will be used first, which is overridden by the style, which is overridden by the view. I think this is kind of interesting because most views in Android, it's only single inheritance for styles, right? It's not like you can set multiple styles like you can in CSS and have them compose, versus, software engineering kind of tells us like to favor composition over kind of inheritance, right? So it forces you down a particular route. So it might be tempting to always favor, say, this is a one exception. TextView offers this extra kind of style almost. So I should maybe favor always using text appearance and then save the style for perhaps some other attributes of which I want to use more widely. But be careful with that, because text appearance generally only supports character level styling. So if you take a look at, this is the definition of text appearance, which defines all the attributes that it understands. And notably absent is anything which is at the block level. So something like line height or line spacing multiplier isn't supported by text appearance. So be careful if you're trying to set those attributes. So when you're setting these kind of attributes, I think there's another styling feature which I don't think is very well known, which can be really, really helpful here, and that's default styles. Who's using default styles? Overriding them, defining your own? Very, very few. I don't think many people use this. I think the best way to understand default styles is to think about the humble Android button. When you drag a button onto your kind of like design surface, it has a background, it has, with a color and some text and some elevation and so on. Where do those come from? If you click into the button class itself in Android, it's pretty sparse. It extends TextView and not a lot else. But one thing it does do, if you look at the toArg constructor, which is what's used when you inflate a layout, it sets the third parameter to be this android.r.attra.button style, which is its default style. And what that is basically a point of indirection, saying that if other styling information isn't supplied, like this is the kind of the last resort place to pull this styling information from. So if you look at the theme, so this is from the default material theme, it defines this attribute in its theme and points it towards a style, and that style is where the styling information is defined for buttons by default. So that's default styles. Basically, it's a way to set some defaults for it. And I think that's going to be hugely helpful for typography. Because quite commonly you want to set, like, say you have a body text style, which is the same text you want, like, most text fields in your application to pick up from, else you want to vary from it. Like, it can be, error prone and not very dry to have to kind of copy and paste that, text appearance or style and remember to apply it everywhere you do a new view. But say you do a refactoring or you have a new team member come in, they have to know about applying this. What can be more kind of resilient, I guess harder, is to apply it as a default style to your whole application so that all text views will get this by default, and then you can style on top of it as needed. So the way we do this is TextView itself defines this default style, this TextView style. Which in the material theme points to this, which defines a bunch of attributes which you can style on the text view. But it's this point of indirection, right? So you can define your own. So in your theme, you can also define a text view style and point it to your own style and inherit that style from, say, the material text view style or app-compat, and then override the default text appearance or other things not supported by text appearance, like the line spacing multiplier or line height, and set them up here. So they're going to be the defaults and used everywhere. So if we go back to that precedence hierarchy we talked about, it actually looks a bit more like this, because default styles, the default style will be, it fits in there, basically. But there's one more thing you can actually think about, is that if you look at how styles, or how you obtain styled attributes, they actually will look in one more place if it isn't specified in the default style, which is the theme. So generally, we recommend not setting styling attributes in a theme, it's not where they belong. But there's one notable exception, which I think is really useful for text, which is if you want to set the font to be used everywhere throughout your application, it can be a pain to go and set it every text view or text appearance or wherever you're using it. So a helpful way to do this is actually to use this fallback mechanism, the fact that the styling system will look in the theme for a value, and use that to set the font family at the theme level. So here I am, this is the kind of top level theme definition for my app. Instead of doing a theme attribute, I'm actually setting a style attribute, which I say is normally a no-no, but in this case can be useful to set the default font family to that latter that we wanted to use. A word of warning is that you might have done something like this and then said, oh wait, why is my toolbar still in Roboto? What is going on there? What's going on there is to think back to that kind of precedence order we talked about. If you're defining the font family in the theme, it will be overridden by anything which is higher specificity up the precedence order, as it were. So if you look at toolbar itself defines a default style, and in its default style, it defines a text appearance for the title toolbar, which itself sets a font family. So that's going to be more specific than the theme, and as such, it won't get picked up. You can, of course, fix this. You can set your own toolbar style, which sets a title text appearance, which has your font family, but it's something to be aware of, really. And one final tip on styling is that while you do the file new project and get a new Android project, it gives you one single styles file. You don't have to stick to that, right? The build tools don't care what you call your files. And as such, it can be really, really helpful to organize them differently. So for example, you might separate out the widget styling from the app's themes, from your text appearances and so on. You might put in typography or text appearance or whatever you want to call it. At this point, I'll definitely give a big shout out to Cyril Mottier's talk yesterday about themes and styles, where he went into a much, much more complex and extensible organization style. So I highly recommend checking that out.
So I know you've been speaking a lot, but I know you're not done with the design. And I know that you want to improve this even more.
Yes. Yes, so far we've been looking at kind of the text level, the text view level styling. But when you're designing a layout like this, you actually want to get a little bit more fine-grained. For example, the title here, I wanted to set in two colors, so I wanted to emphasize the title over kind of the byline. For the kind of authors, I wanted to make those kind of appear clickable with an underline and color. And then in the abstract, I wanted to get a bit more variety in here. So I'm using bullet points for some of the features. And one thing I want to call out is when referring to code styles, I think it's much better to have that in a kind of monospace font and then use a background color to denote that that's a kind of a code block. But when I was setting that with a gray background, it became too kind of prominent. So I actually reduced the size of the text as well to kind of like counteract that. How would we build that?
So to do this, let's start with the headline. So we see that by default, we set the text color, right? But what Nick wants is actually from the 12th character up to the end to have another color. So it would be great if you could do this with a text view, but you can't because the text view doesn't do line wrapping around other objects. So this means that what we need to use is a span. So more precisely, spans are just markup objects that can be attached to a string from a start index to an end index. So more precisely, here we would use a foreground color span of a certain color from index 12 up to the end. But then Nick was saying that for the code block, he wants several things. So we want a background color span, we want an absolute size span because we want to change the size, and also we want to set a typeface span because we want to change the font of the text. So this means that we can apply in the same time multiple spans to the same block of text. So if you look at what we need to add, the background color, absolute size, typeface span, we can see that the first one, the background color, just changes the appearance of the text. So this means that when our text needs to be drawn, it doesn't need to go through all the measuring because the size doesn't change, it's just the color. So it's just an appearance affecting span. Whereas both the absolute size and the typeface are affecting the size of the text. So this means that these are metric affecting spans. Also, what Nick wanted was to show bullet points for all of these items that we're speaking about today. So in order to do this, we would use paragraph spans. So what's a paragraph? A paragraph is defined based on the new line character. So more precisely, we would apply bullet spans from the new line up to whatever our line end is. So what's important to remember here is that paragraph spans should be applied really from the new line character, because otherwise, well, chances are most of the times the span just doesn't apply. And in some cases, you can end up with stranger things. So take care of that. And then we can also apply multiple spans to the same text. Okay, so overall, we said that we can split the type of spans that we have into character span and paragraph span. And then the character span can be split in appearance affecting and metric affecting. So the framework provides classes that do this for us. So appearance affecting is defined based on using the update appearance interface and the character style abstract class. Whereas the metric affecting is implemented based on the update layout interface and character style. But more precisely, all of these metric affecting spans extend from, well, metric affecting span. So therefore, this is the one that you should remember. And then for the paragraph span, well, we have the paragraph style interface. So the framework already provides a lot of spans for us. So for example, we have these for appearance span. We have quite a lot for metric affecting span, and even more for paragraph span. So I would say that whenever you need to style your text, first check what the framework already has for you and just use what it is there. Okay, so we've set the background color, we set the size, and we use the typeface span of a typeface to set the font. But the thing is that this class is, or this parameter in the constructor is only available from P. Before P, you couldn't set a typeface span based on a typeface. So what do we do in order to fix this? We will need to create a custom typeface span that in the end just does the same thing as P is doing. So we would implement a metric affecting span for our custom typeface span. So because we're implementing a metric affecting span, we need to override two methods to define what should happen when the measure state is updated and what should happen when the draw state is updated. And for both of them, we're getting the text paint as a parameter. So for both of them, we want to do the same thing. We want to keep the initial style of the text. So for example, if we've set the text to be italic as a style in the text view, and then we want to apply on top of this the new font. So we want to apply that, what font did you use there?
Lato.
Okay, we want, for the text, for the code block?
For the code block, that was Roboto Mono. Okay,
so we want to apply the Roboto Mono on top of whatever was there. But we see that if we're working with the typeface, with the text paint, we also have access to all the other elements that we need for our code block, because all we want to do extra is to set the background color and to set the size, and the text paint gives us all of these. So why not just implement a code block span directly? So here it will still be a metric affecting span. Things will be pretty similar to the custom typeface span, but on top of this, we would also set the background color and the text size. Okay, so now we have two different ways of implementing things. We can either set spans by applying multiple spans, or out of which one is a custom one, or just create a custom one from the beginning. So how we decide which one to use? Well, the thing that you need to keep in mind is, what do you do with that text? Do you need to pass that text from one activity to another, or in between processes? So what do I mean in between processes? Even when you want to, let's say, copy the text of a text view into an edit text, even if it's in the same application, that's still an inter-process application, because the text needs to go through the clipboard service, which is another process. And the same thing also happens when you want to copy the text from one app to another. So one thing to remember is the hierarchy that Nick mentioned before, and the fact that in the end span is on top of all of this. So this means that whatever styles you're setting for your own text views, even if it's a comical font, the span will be set on top of this. So there's another thing to remember, that whenever you're passing spans like this, independent if it's like via an intent or by copying, only framework spans are passed. So this means that I'm losing all of that all of those custom properties or custom spans that I've built, and I end up with a text view that also has a comic font.
What about the performance impact?
Between the custom span, or no, there is no performance impact. Even if you're even if you're setting multiple spans or one span up to a certain level, so let's have up to 10, 20 spans for the same block of text, there is nothing different. The difference in performance would be once you set like hundreds of spans, which would be interesting to see, actually. I want to see an app that has so many spans.
That sounds horrific. Don't do that.
So I kept on showing this class, the spannable string class, but I didn't really talk anything about it. So when working with text and with spans specifically, we have a few base classes that we use, or well, interfaces in this case. So the base interfaces are spanned and spannable. And the difference between them is whether the text and the markup are mutable or not. So for example, spanned defines mutable text and immutable text and immutable markup, whereas with spannable, we only have mutable markup. So this means that we can only modify the markups, the spans that we attach to it. And then we have some concrete classes that implement these interfaces. So we have a span string that has immutable text and markup, a spannable string that has mutable markup, and a spannable string builder that has both immutable text and immutable markup. So which one should you use? Even if the implementation under the hood is different, you should actually use the one that fits your case best. So if you're working with text where you're only modifying the markup objects that you're attaching to it, use a spannable string. If you're not modifying the text at all, you just want to get the spans from it, use a span string. And similarly, if you want to update both the text and the markup, use a spannable string builder. Okay, I'll keep this as a cheat sheet there in the corner, and let's look again at the code block. So whenever you're setting the text, you're used to calling setText. Let's see what happens under the hood. So what TextViews is doing, the first thing that it's doing is to copy that text, because it wants to make sure that whenever you're modifying the text outside the text view, your text view won't be updated. So it keeps a reference to the text as a spanned string. So it keeps an immutable reference to that, or immutable value of that text. But what if we actually want to modify the text, or we want to modify the spans? Then we can use the setText based on the text and a buffer type spannable. So this means that under the hood, the text view will keep the object as a spannable string. So this means that we are able to modify the markup. So this means that we can also get the text as a spannable, and we can change the spans attached to it. So under the hood, the text view also has a span change listener. So it knows that you're adding or you're removing markups to that text. So it means that whenever you're doing a change, so you're adding, for example, here we're adding a new foreground color text, it already updates the text automatically for you. So you don't need to call setText again. So this also means that you don't need to go through all of that object copying and so on. Okay, but let's say that we want to change an internal property of the span. So in this case, we have our custom typeface span, and we want to change, instead of roboto mono, to use another one. Well, in this case, we don't have that listener, because the listener just tells us if something was added or removed in terms of spans, but it doesn't know that an internal property changed. So it means that we need to tell the text view that it needs to draw or it needs to measure the text again. So more precisely, we need to call either invalidate or request layout, depending on what kind of property we are changing. So for example, here, because we're changing the typeface, it means that this is a metric affecting span. So it means that we need to call request layout. But if we would just change, let's say, the color, invalidate would be enough, and then just trigger a redraw. Okay, whenever we're setting the text, the first thing that the text view does is also try to measure it. But we've seen that this measurement of the text takes actually up to 90% of the entire text being laid out. So this is why we created in P the pre-computed text class. So this allows us to compute the measurement or measure the text on a background thread. So more precisely, on the UI thread, we would get the text metric parameters. And then on a background thread, we would call precomputed text.create with our text. And then once the text was computed, on a UI thread, we would update the text view. But the thing is that the text view is very eager to render whatever we're giving. So this means that if we're giving it a very long text, like a book, it will actually try to measure and render the entire text. So while doing the pre-computed measure, or measuring the text on the background thread helps, there is even more that we can do. So what we can for long text is just to split the text into paragraphs or screens and use a recycler view to display that text. So like this, we would split our text into different chunks, and then we would use all the capabilities of the recycler view to display it. So it would only display the text that is needed. Okay, and then using all the recycler view properties, you can just style it to make it look like it's one text. So under the hood, you're using recycler view, but your users don't know that these are separate things. But we can improve the performance when working with Recycler View even more. So usually in the adapter, you tend to use, let's say, a list of strings. But we can defer this actually, or we can move this to a background thread by using a list of spannable in the adapter. So more precisely, whenever, let's say you're getting your data from the repository on a background thread, and then you would change that business data to the UI objects, also on the background thread. And in the same time, when you're preparing your data to be displayed, there you should also convert your strings to spannables. So you could also style the text and prepare it to be displayed. OK.
Phew, span. Right. That word has lost all meaning to me. That's all we've got for you today. Hopefully we've outlined some of the decisions that designers think about when they're designing what text should look out in order to convey information better and to convey hierarchy and meaning better, as well as talked about how awesomely Android now supports it and some of the new features, especially in P, and perhaps maybe, I don't know, coming to a support library near you at some point. As well as deep diving into fonts and using styles and themes and then spans. So thank you very much for coming. I don't think we have time for questions, but grab us at the end or online if you'd like to talk to us about text. And go forth and make text layouts that don't stink. Cheers.
Thank you.
Good?
Yeah.